Assalamualaikum viewers, welcome to my channel Mathematics Zone. In the unit techniques of integration, we have started theorems on integration. The second theorem is if a is a constant, then integral of product of a constant and the function will be equals to the product of constant and integral of function f of x. So let's start the proof. Firstly, we will differentiate the right hand side of the above equation. So I'll write the statement there, that is differentiate right hand side of above equation, that is the product of a and integral f of x d of x. So when we differentiate the right hand side, then derivation is applied, d by dx of square bracket is used here, a integral of f of x d of x. One thing remember students, each operation you apply on a solution of any question or any proof, you will write the statement in the solution so that the examiner will understand what are you going to do in the question or in a solution. It's necessary. So when derivation is applied, the constant comes outside of the bracket because derivation is applied only on the integral, that is integral f of x d of x. As we know that when derivation is applied on integral of function f of x, that is also our first theorem that I have proved in my previous lecture. Here you can see how derivation is applied on integral function and how it is equals to the original function, that is f of x. Basically derivation and integration are inverse operations on each other. So when we use it in the solution of any question, then derivation and integration will be cancelled out and remains the function f of x. So in the above equation where derivation is applied, we will give the name of equation 1. So equation 1 becomes if d by dx of integral f of x is equals to the function f of x, then equation 1 becomes d by dx of bracket integral of a integral of function f of x will be equals to a f of x. Here in the equation 1, d by dx of integral f of x is replaced by the function f of x. Thus we can say that the product of constant and integral of function f of x is antiderivative of the function a f of x, that is given on the left hand side of the theorem. You just keep one thing in your mind, that we have given the function a f of x, and when we apply integration on it, then its antiderivative is a and the product of integral of function f of x. In other words, you have to be proved that when derivation is applied on right hand side of the theorem, then its derivative will be equals to the original function, that is a f of x. So you can write here that integral of product of constant and the function f of x is equals to product of constant and integral of the function f of x. So here our second theorem is proved. So you just have to understand the logic that if a integral f of x d of x is antiderivative of the function a f of x, then its derivative must be equals to the original function, that is a f of x, that we have proved in this theorem. So it is proved that integral of product of constant and the function f of x is equals to the product of constant a and integral of function f of x d of x. Hopefully you will like the video. Please share the video, subscribe the channel. Thanks for watching the video.